Hi, and welcome to today's NetBeans live demo. Today, we're talking about how to test MTU on IP network. So before showing how you can test MTU, let's talk a little more about this parameter, which is really important on IP networks. So the MTU stands for maximum transmission unit. And as you can understand, it defines the byte size of the largest protocol data unit that is allowed to pass. This is not something that is globally pushed to a network, but is defined on a per device, per interface basis. So in the end, you will see this setting applied to individual network or layer 2 interfaces on a router, switch, as well as your laptop. The majority of laptops have an MTU, for example, of 1500 bytes. Different story is for routers and switches, where they can go from anywhere between 1500 bytes to, for example, 9000 bytes. And as you can see, just to give the basics of an IP packet, in this case, we have an ICMP packet. You can see that in an ICMP packet, in this example, we have 20 bytes of IP header, 8 bytes for the ICMP header, and then 1472 bytes of ICMP payload. If you sum that, the total layer 3 MTU is equal to 1500 bytes. So MTU mismatch is happens when the packet size is larger than the interface MTU. And based on this condition, different things may happen based on the type of interface that is seen this packet or frame coming through it. So layer 2 and layer 3 have different behaviors. And another thing to consider is like the don't fragment bit, which is a IP field on the packet, which says if you see this bit set to 1, so don't fragment is set to true, the router should not is not allowed to fragment the byte. That means it will have to discard it and send back to the source host an ICMP type 3 code 3, which is also called fragmentation required message. Different stories for layer 2. Layer 2, in fact, as we can see in the next table, they discard the packet if they are larger than the interface MTU. So really, the behavior of a switch versus a router or a interface, if it's router or switches, is really different. And also based on, again, the DF setting on your packet. So again, as you can see, of course, if a packet size is lower than the interface MTU, everything is good for both layer 2 and layer 3 interfaces. If the packet is larger than 1500 bytes and the interface is set to 1500 byte MTU, then a layer 2 interface will silently discard it, while the layer 3 will fragment if the DF bit is not set. It will fragment the packet, send it through, and then the destination host will have to reconstruct the original packet. On the other side, if the DF bit is set, and again, the packet size is larger than the interface MTU, again, in layer 2, it will be discarded, but in layer 3, it will be discarded as well, but the source host will be notified. So keep this in mind when you're troubleshooting connectivity issues that you suspect are caused by MTU. Very important. So how can you test MTU? If you have any Linux, Mac, any command line interface, you can issue a ping with -d, don't fragment, -s, which is the packet size, the payload size set to 1472, and then the destination host. This is a good way to troubleshoot end-to-end if the network can deliver packet size of a specific size. And again, the default option of ICMP, if you don't specify this, is a 56 byte payload with 8 bytes of ICMP header and 20 bytes of IP header. So if you do the math, it's about 84 bytes of packet size. While again, if you want to do a 1500 test, you'll have to set the payload to 1472. And here I'm showing you for last in NetBeans how you can do the same test but through the graphical interface and of course push this to all your sensors. So again, we have an option to specify the MTU size, and the user can also set or not set the don't fragment bit and then specify the payload size. That said, I hope this quick short demo was beneficial to learn more about how you can test MTU with open source tools and NetBeans.